Okay, today's lecture is Systems of Nonlinear Equation in Two Variable. Last class we did System of Linear Equation Two Variable. This time we're going to look at a mixture of different types of equations. For example, when you look at the first problem, you can see you have quadratic right here. Quadratic, because we have a square right here. This is quadratic. This one is going to be linear. If we look at the next one, we have a circle. How do I know it's circle? Because we have x squared and y squared, right? We have circle with line, linear, right? So we're going to look at mixture of different types of equation here. When we look at the first one, we're going to use the substitution method again. In order to solve the substitution method, you're going to solve one of the variable, right? So pick one of the equations, and I will probably pick the linear and solve that for a variable. So if I wanted to solve that for y, I will have 3x minus 9. Once you solve one of the equation to a variable, then you're going to replace that into the other equations. So we're going to start with the first equations, and whenever I see y, I'm going to replace with 3x minus 9. And look like I have only one variable x. This is going to be quadratic. So let's see if I can simplify my right side by distributing 2. Then 6x minus 18 plus 10. And because this is going to be quadratic, I wanted to put it all one side. And this 2 together, this is going to be negative 8. And put it on the other side of the equation will be plus 8 equals to 0. So once you realize quadratic equations, you know you wanted to make a standard form equals to 0. And once the standard form equals to 0, if you can factor. If you cannot factor, you can use completing the square method or quadratic formulas, right? And this gives you x equals to 2 and positive 4. So once you have x equals to 2 and positive 4, then you can replace those values into one of these three equations. 2 was given and 1 was the transform. And I will probably put it onto the transform because it's already solved for y. Then when x equals to 2, I will have 3 times 2 minus 9, which will be 6 minus 9, that's negative 3. And you can also have x equal to 4. Then you're going to have 12 minus 9, that's equal sign. So then you will get positive 3 on this one. So you have two set of solutions. When x is 2, y will be negative 3. And when x is 4, y is 3 for that problems. We're going to try another example. This time, like I mentioned, we have linear and we have a circle. Right, so let's see. I'm going to solve the linear for x variable. Then I will have 3 plus y for x. And I will replace that with your x on the other equations. So I will get y plus 3. 3 plus y plus 3, same thing. And minus 2 square plus y plus 3 square equal 4. That gives you y plus 1 square plus y plus 3 square equals to 4. Y plus 1 square, when you FOIL this, make sure you don't distribute, right? Square. So when you FOIL this, you get y square plus 2y plus 1. And when you FOIL y plus 3 square, you get y square plus 6y plus 9. And look like this is going to be quadratic, right? So I'm going to move the positive 4 to other side, make it negative 4 equals to 0, and combine the like terms. So positive y square, you get 2y square plus 2y and 6y is 8y. And you have 1, 9, and negative 4. You get plus 6 equals to 0. And I see that greatest common factor 2 out, then you get y squared plus 4y plus 3 equals 0. When you factor that, you get y plus 3 and y plus 1 equals 0. This 2 right here in front, you will not get any solution from there. Why? Because you don't have variable. But this 2 term, you do have a variable y, and it gives you negative 3 and negative 1. So again, you have 2 solutions. So look like if you had circle with line paths, and you have 2 solutions right there, right? So one point have y value negative 3, the other point y value negative 1. So when we replace that into one of your other equations, you should be able to find your x. So your x come from when y is negative 3, it will be 0. When y is negative 1, it will be 2. So again, you have a 2 set of solution. When x is 2, y will be negative 1. When x is 0, y will be negative 3. Let's see, example 2, we're going to solve the system by this time using additional method. We already know how to use additional method, but this time it's not linear. So when we're looking at the first problem, we have 2 circles, right? 2 circles. So let's see how we're going to use additional method to solve this system of 2 circles. So the additional method is you're adding 2 equations to get rid of one of the variable. Let's say if I wanted to solve for x first, then I need to get rid of variable y. Right now, you have a same value of y. So in order to add to get rid of y, you need to make one negative. So I'm going to just use the first equation as it is. But for the second one, I'm going to times by negative 1. Then I get negative x squared minus y squared equal to negative 10. And when you're adding those 2 equations, you get 3x squared and no longer y variable. And you get positive 3. And divide both sides by 3, you get 1. So you have x squared equal 1, so your x should be plus minus square root of 1, which is 1, right? So you have two solutions. X can be positive 1 and X can be negative 1. So when X is positive 1, let's see what Y can be. I am going to replace it in the second equations. Then when X is 1, what Y will be? Y squared will be 10 minus 1. So Y squared should be 9, where Y you get plus minus 3. So here, when X is 1, you can have negative 3, but also you can have positive 3. Let's see, what about when X is negative 1? You replace it into X squared plus Y squared equal to 10 again. You have negative 1 squared plus Y squared equals to 10. Look like you're squaring negative, so you're going to get exactly same thing as what I had when X is positive 1. So I will have Y squared equals to 10 minus 1, where Y is going to be Y squared will be 9, where Y is going to be plus minus 3. So here, when X is negative 1, I got negative 3 and positive 3. So I have set of 4 solution there. The next problem B, we have circle and parabola, right? The first equation is quadratic. Second equation is circle. So if I wanted to use additional method, I'm going to rewrite this problem into comparison. So I wanted to see when I'm rewriting the first quadratic equations and start with X squared, and then I have I wanted to put it all one side, so it will be negative X squared, and then I have plus Y equal to 3 is what I have. So I just rewrote this into the same order form of the other equations. And then if I wanted to write the circle equations, I have X squared and plus Y squared. I'm not going to write my Y squared with Y at the same line because they're not the same term, right? So I will write a Y squared different line as Y, right? And this is equal to 9. And when we're adding this, negative X squared, positive X squared, they cancel out. And I end up getting Y squared plus Y equal 3 plus 9 is 12. So this is going to be a quadratic equation with Y variable, right? In order to solve Y, I can this is quadratic, so I wanted to write it into the standard form. Descending order equal to 0. And see if I can factor this. So my Y is going to be negative 4 and positive 3. And with that in mind, so this is my 2 solution for Y. I'm going to replace back to see if I can find my X values, right? So I'm going to replace it into let's replace it into my quadratic equations. Quadratic, right? So then I'm going to replace y equal x squared plus 3, and I'm going to let y equal -4 and see if we can find x. That will be -4 equal x squared plus 3. And when I subtract 3 both sides, that will be -7 x squared. And when you square root each side, I end up getting plus minus -7 equals to x. This is imaginary units. It's not a real numbers. So this will give me no solutions. What about for y equals to x squared plus 3? But then I'm going to let y equal 3. Y equal 3, I get 3 equal x squared plus 3. And when I subtract 3 both sides, I get 0 equal x squared. And I know my x is going to be 0. So here, when x is 0, my y will be 3. Even though I found 2 solutions here, this -4 didn't work out because my x, I end up getting no solutions, imaginary units. So we need to cross out that solutions. And when I replace 3 for y, I end up getting 0 for x. So this is going to be only solutions I have, a point. So when I draw a circle and parabola, this only made 1 point. So I can imagine my graph will be something like have a circle and parabola attached, something like that, right? So that's going to be one solution for that problem. So this is something I can imagine having just one point.